All right, hello. My name is Kenneth Richardson, and I will be discussing nuclear power and with a focus on obtaining uranium from salt water. When one thinks of the word nuclear, the first thing that comes to mind might be a devastating explosion, or a toxic wasteland, or the possibility of being bitten by a radioactive spider and becoming the coolest superhero ever. And while most of those are definitely real possibilities, the majority of nuclear power is focused in providing the world with clean, highly concentrated energy source. Since the process of nuclear energy is through nuclear fission, since processing and harvesting nuclear energy is through nuclear fission, which is the splitting of the nucleus of the atom, it is technically a renewable resource. But the primary fuel source used in nuclear fission, uranium, is limited, making the fuel source as a whole non-renewable. This limitation is compounded by the fact that only a specific isotope of uranium, U-235, is used in nuclear facilities and only accounts for 0.7% of the available uranium in the Earth's crust. That being said, developments in obtaining uranium from saltwater may give nuclear energy a much more sustainable future. As of 2015, approximately 10.6% of global electricity was generated by nuclear energy. The United States is leading in this market, with 32.3% of the world's energy being exported from the United States. They also utilize 19.3% nuclear energy as electricity domestically, according to a 2017 study by the International Energy Agency. This study also found that in 2016, the US had the largest increase or decrease of CO2 emissions compared to 5 major economies who managed this feat, where most others saw a rise in emissions. This was due to further deployment of clean energy. France utilizes the most nuclear energy domestically by far, at 77% nuclear energy being used for domestic electricity. This has contributed to the nation having the lowest electricity costs in Europe, as well as having very low CO2 emissions. But nuclear energy presents dangers as well. The most recent example of these dangers was in the 2011 Fukushima nuclear reactor disaster, in which an earthquake and tsunami caused a power plant to overheat and release radioactive material. This and the Chernobyl disaster have added much apprehension towards nuclear energy. Furthermore, uranium mining has negative impacts on the surrounding environment, including negatively polluting surface and groundwater. On the other hand, chemicals in uranium extraction from water were found to be non-toxic to marine life in a 2016 study conducted by the Marine Science Laboratory in the Pacific Northwest National Laboratory. This study also found that depletion of uranium rates in the ocean should not negatively impact its direct surroundings. Not only is the impact less negative, but there's also much more uranium in the ocean than there is on land. Although in minute concentrations, at 3.3 parts per billion, there's 4.5 billion tons of uranium in the span of the ocean, where only 17 million tons are on land. This supply is constantly replenished by natural chemical reactions between the rocks and ocean water that maintains itself faster than we can deplete it. Researchers at Oak Ridge National Laboratory extract uranium by coating polyethylene braids in a uranium abstractive substance called amidoxine. These braids can be submerged for up to a month until they're sufficiently coated in uranium and then turn yellow. Once they're surfaced, the uranium is removed and the braids are treated with an acid treatment so they can be reused. And right now, the process of this has only been tested in laboratories. It's not like used throughout the world. But this is kind of like a diagram of how they would use it. They would kind of have these tracks that are going like many meters across the floor of the ocean, and they'll be down there for about a month, and then they'll use radio signals to send a signal down to release the braids to come up and extract the uranium. But the reason why this is not more widespread is because it's very expensive, costing $200 per pound of uranium compared to mining, which only costs between $10 and $120 per pound. This cost imbalance is the main reason why this isn't more widespread. Stanford University is making traction in 3 key issues affecting how much uranium and affecting the cost effectiveness of this procedure, including how much uranium can be collected in a given area, how fast the ions are captured, and how many reuses the braids have. This study found that by using a hybrid carbon amidoxine wire charged with an electric current, they were able to capture 9 times more uranium than traditional wires, along with taking longer to become fully saturated and having 3 additional uses compared to the normal ones. Once this process becomes economically feasible, nuclear energy can officially be counted among renewable energy resources. Achieving absolute reliance on clean energy will likely be the result of multiple forms of energy to accommodate the massive global energy use, which is expected to increase by 28% by 2040, according to a 2017 report by the U.S. Energy Administration. Nuclear energy's future in that climate may rest on the innovations of uranium extraction from seawater, which are well on their way to revolutionizing the way we perceive nuclear electricity.